In this scientific reenactment, we have attempted to show what human life would be like if males made up 80% of the population. Horrifying? Yes. However, this horrifying scene is the reality for another species on our planet, Sphenodon guntheri. Sphenodon guntheri belongs to the clade Sphenodonta, a group of organisms commonly referred to as tuataras. Though lizard-like in form, tuataras have several unique features that separate them from lizards and other reptiles. Tuatara inhabit the islands surrounding New Zealand. They are exceptional among reptiles for their affinity for cooler climates and for their slow development. Tuatara have an average lifespan of 60 years and take 10 to 20 years to reach sexual maturity. Additionally, adults reproduce only once every 4 years. Females lay clutches of 5 to 18 eggs, which take up to 12 to 15 months to hatch. Interestingly, the sex of the offspring is determined by the temperature at which the egg is incubated. The pivotal temperature of sex determination is 21 degrees Celsius. It was found that 80% of eggs incubated at 20 degrees Celsius produced females, while 80% of eggs incubated at 22 degrees Celsius were male. This led scientists to investigate the effects of climate change on these temperature-sensitive creatures. In this study, researchers wanted to investigate the demographic consequences of sex-biased populations on S. guntheri. Before population modeling could begin, the researchers needed to collect basic species demographics. Scientists traveled to North Border Island in New Zealand, where they then collected information concerning the tuataras, population size, roughly 500, female fecundity, and mating behaviors. These parameters were then used to predict population viability using computer modeling programs. 3 different population effects were tested. One model was concerned with the effect of inbreeding on the continuing tuatara population, and ran a simulation at varying sex ratios and in the presence or absence of inbreeding to determine population success after 2,000 years. Sex ratios tested started with 50% male hatchlings and were increased by 2.5% increments until a 100% male population was tested. Researchers found that as long as hatchling sex ratios remained less than 75% male, populations of tuatara persisted for at least 2,000 years. However, a higher degree of inbreeding resulted in a smaller percentage of the population surviving past 2,000 years. A second simulation attempted to estimate the amount of time the S. guntheri population will survive based on global temperature trends. The sex ratio of hatchlings in 2002 was 36% male. Based on current global temperature trends, the model predicts that 100% of hatchlings would be male by 2085. Given these data, it is estimated that the S. guntheri population will be extinct within 4 generations. Finally, the researchers modeled 2 various intervention techniques. In one, humans shaded the nests and produced mixed-gender hatchling populations. In the other, humans produced 100% female clutches in a lab that were then introduced into the wild. While both of these options extended the tuatara population outlook, both required extensive upkeep and required human intervention at least every 2 to 4 years. So what's the big picture? Global climate change can skew sex ratios in species who undergo temperature-dependent sex determination. In the case of Sphenodon guntheri, current rates of global temperature increase could lead to an all-male population by 2085. In addition, populations containing a male sex ratio of greater than 75% will experience greatly reduced genetic diversity due to increased inbreeding. These outcomes would doom S. guntheri. However, not all hope is lost. Natural selection may act to preserve S. guntheri. Climate change could select for modified nest characteristics such as deeper, more shaded nests, resulting in cooler, more female-skewed clutches. In addition, human intervention in the form of harvesting and incubating eggs to create all-female clutches and releasing the hatchlings back into the wild may be another option for saving S. guntheri from extinction. Humans can also work to reduce our carbon footprint to slow the effects of global climate change.